Okay, so today we're going to be looking at lesson 70, talking about probability and designated order. You guys might remember this from last year's curriculum in the 8-7 book. We talked about probability. You know, probability, as the book puts it here, is the study that is based on the study of outcomes that have an equal chance of recurring. So if you take a dice or a die, they call it a die. I always say dice. How many of you say die for one die? How many of you say dice for one die? I say dice too, but really the proper term for one of those little square cubes with numbers on it is a die. So when you roll those and you're trying to figure out, wow, I wonder what the chances of me rolling a 1 might be, that's the study of probability. So we're going to learn how to figure that out. And then also, how can we figure out if I take a coin and I flip it and I say, what's the chance it's going to land on heads the first time and tails the second time? So you create an even greater probability experiment when we're looking at it that way. So we're going to look at two different things today. One of them being what happens when I roll a dice or flip a coin and I want to try to get heads, or I want to try to roll a 6. The other one is, what about when I roll it multiple times, or I flip my coin multiple times, or what's another probability problem you guys have been seeing for many years?
What's the probability of like rolling a dice and getting greater than a number?
Well, that too, but what is something else that we can, not just a dice or a die or a coin, what's something else where we've seen probability problems? Do you remember?
Cards.
Cards would be one. What's another one? There's another one you guys have been seeing probably since 3rd grade maybe. It comes in colors. You can roll them on the floor. Little marbles, you know, they always talk about probability problems of colored marbles in a bag, and if you reach in and draw out colors. Remember those problems? We saw a lot of those last year too. All right, so let's go ahead and look at, in your packet for lesson 70, the very top of this gives some very good vocabulary terms and states what they mean. So probability is simply the measure of how likely an event is to occur. And each possible result of a probability experiment is the outcome. So that's what we're always trying to figure out. What is the outcome of rolling a dice and landing on a certain number, or flipping a coin and landing on either heads or tails? The sample space is the set of all possible outcomes. So when I think about a die, what would be my possible outcomes when I roll that dice one time? What are my possibilities there? What exists?
1, 2, 3, 4, 5, 6.
Right, it can roll on one of those 6 numbers, right? That's your sample space for a die, for example. Okay, and we'll see that as we solve certain problems here, what the sample space is for each particular event. And then an event is an outcome or set of outcomes. Okay, so we're going to be looking at how these work, and you're going to remember these from last year because we did these, and I remember sitting on a Zoom call doing these for days. Do you guys not remember?
I remember doing these last
Okay. All right, so let's look at, we're going to go right on to an example first in the book. Let's say this is actually 70.1 in the book, and it's on page 285. I don't have written down for you what each one of these say, but I can read those, or I can have you read them aloud. How about if I do that? If you're in your book, and Bailey, you look like you're there, can you read the first example up there, 70.1?
A fair coin is tossed 3 times and comes up heads every time. What is the probability that on the next toss it will come up heads?
Okay, good, thank you. And one more thing I do want to say to you, if you look at the bottom of page 284, I failed to mention this. In that little box down there, Arlie, can you read what that says in the box on the bottom of page 284, please?
The probability of any event is a number between 0 and 1 inclusive. If no outcome satisfies the requirement, the probability is 0, and if every outcome satisfies the requirement, the probability is 1.
Okay, and that makes sense to me because if you think about a die, and I want to know what my chances are of rolling a 2, I'm going to have a 1 in 6 chance of rolling that 2, right? So that's between 0 and 1. And all of our probability, all of our outcomes are going to be a number somewhere between 0 and 1. If there's no possibility, then it remains a 0. There's no chance. So if I said to you, let's roll this dice, what are my chances of rolling a 7?
0.
0. What are my chances of rolling a 20?
0.
How could I get those numbers?
Multiple dice.
Right, rolling multiple dice at the same time. So in the case of one die, that would be 0. There's no chance of rolling an 8. 1 would be if there is a die that I give to you and all the sides of that have a 1 on it, and I say to you, what are the chances of me rolling a 1? Every chance, right? So the closer you get to 1, the better the chance of rolling that 1. Okay, if it's absolutely impossible, then your chances would be 0. But typically it's somewhere in between 0 and 1. Okay, so let's look at this. So Bailey read this. A fair coin is tossed 3 times and comes up heads every time. I want to address just a couple things about this. What's the probability that on the next toss it will come up heads? First of all, I want to address 2 terms with you. Independent event and a dependent event. Today we're only going to be looking at independent events. So an independent event, any thoughts? You guys remember from last year what an independent event was? If you think about a dice, and I'm going to roll, all right, here's one. A bag of marbles, and I have 3 red marbles in there, and I have 2 blue marbles in there. And I say, what are the chances of me pulling out a red marble when I reach in the bag?
Would that be a dependent one?
Okay, that would be independent, because pulling that red marble out is nothing affects it other than the fact I reach in and pull it out. So what are my chances of getting that red marble?
3 out of 5.
3 and 5, right? Because the total is 5. There's 2 blue in there, but my chance of reaching and pulling out a red is 3 and 5. If I put that red marble back in and I ask the same question, you're going to answer the same way. What are my chances of pulling a red marble out? You're going to say 3 and 5. But if I don't put that red marble back in, what happens now?
1/2.
Okay, so my chances are now 2 and 4, which is 1/2. We always do reduce it. But that becomes a dependent because, well, it's actually still independent, isn't it? Because, yes, it's actually still independent because I'm asking the question based on how many are in there. So we're not even going to be looking at dependent events today. We're only going to be looking at independent events where nothing I do affects what I pull out of that bag or what I roll on my dice. All right, so let's see. Let's go back to this situation here. All right, so here's how we write this. So tossing a coin is an independent event. How do I set this up? So I set this problem up. The probability of rolling, or flipping, excuse me, my coin and landing on heads would be the number of possible, or the number of outcomes, let's see how I wrote this, that are heads. H stands for heads, over the total number in my sample space. And how many are in my sample space? What are my possibilities of flipping and getting a heads? How many possibilities? 2. So in this case, if I flip 1 coin, my chances of getting heads, possibility is only 1 because there's only 1 head on that coin. But it's always over the 2 because there's 2 in my sample space. A coin has heads and it has tails. So that would be my total number in my sample space.
Do we write that somewhere?
Pardon me?
Do we write that in our notes?
No, you don't need to write this in your notes just yet. All right, let's look at 70.2. Can I get a reader for 70.2? Arlie, would you like to take that?
6 green marbles and 8 red marbles are placed in an urn. 1 marble is drawn and then drops back in the urn. Then a second marble is drawn and drops back into the urn. Both marbles are red. If another marble is drawn, what is the probability that it will be red?
Perfect. Okay, so we have some colored marbles in here. I knew we were going to see one of these. 8 of them are red, 6 of them are green. 8 red, 6 green, did I just say? 6 green.
Yeah.
And we want to know what the probability is of drawing a red marble out of there. All right, so we're going to use the same thing and we're going to list this as the probability of a red marble. What are the chances of drawing a red marble? So that's how we write that. P is probability. In parentheses is what you're trying to, what the outcome you're trying to get is. So what is my probability? Ileana, can you help me with that, please?
It would be 8 over 14.
Perfect. Because there are 8 red marbles. That's what I'm trying to get. So the number of outcomes that are, in this case, red, or 8, and the total number in the sample space would be all the marbles in the bag, which would be 14. So let's reduce this. So Bailey, what do I get when I reduce 8 over 14?
Trying to do it in my head.
You can. They're even numbers. Let's see if that takes you as far down as we need to go.
Would it be 4 over 7?
Okay, are we done? Yeah, because this is an odd number, so I can't divide it by 2, and the only other factors of 4 would be 4 or 2. Okay, so we're done. Let's look at the next one, 70.3. Ileana, could you read that, please?
A single dice is rolled 3 times. The results are 1, 4, and 3 in that order. What is the probability that the next roll will produce a number greater than 2?
Okay, so now we're looking for the probability of rolling a number that is greater than 2.
I know.
And we've already rolled a 1.
1, 4, and 3.
Right, 1, 4, and 3. Now that doesn't really matter, right?
Yeah, we don't.
That doesn't really help us in solving the next roll. That's why it's independent. What has happened before has no bearing on what now happens because you're rolling all the dice again.
Yeah, it doesn't.
Okay, and I noticed how you changed that die right up to dice. So we all have that bad habit of saying dice for one die, right? Okay, but it's okay. We all know what we're talking about. Alrighty, so what's the number of outcomes that can be greater than 2? Arlie, help me with that, please.
4 over 6.
Oh, look at that. She's going to give me more than I asked for.
And
Good
we
job.
Reduce it to 2 over 3.
Right, so we reduce that to 2 out of 3. That's the probability. Okay, 4 coming from greater than 2 on a dice. How many numbers can that be? What's my sample space?
6. Right? No. 8.
That's one of the possibilities.
Oh, so all the numbers?
All the numbers that can be greater than 2 is my sample space.
3,
4,
4,
3.
5, 6.
Okay, so 3, 4, 5, and 6 is my sample space. Okay, so there's 4 possibilities, and that's where we get the 4 from. All of these are greater than 2. There's 4 of those available. Total number is the total 6 that live on your die. Okay, next one. Let's look at 70.4 here. Okay, so 70.4 says we have 2 dice that are rolled here now. This is a little bit different. Let me get somebody to read that. Who hasn't read for me in just a couple minutes? Bailey, have you read? Let's get you.
2 dice are rolled. What is the probability that the sum of the numbers rolled is A, 7, and B, a number greater than 8?
Okay, so there's the 2 things we're trying to figure out. What's the probability on those 2 numbers? Now, if you look at the bottom of the book, and this is why I wanted you in here today. Usually I don't have you have the books open because all the answers are there on all the examples, but hopefully we've been working those out without you peeking. But on the bottom here, they give you this table. Do you remember this table from last year? When you have 2 dice that you're rolling, or you're gonna have a different setup for your marbles or for your coins. In this case, we're talking about dice. We have 2 dice that we're rolling. What's the probability that the total of those is going to be 7? And the next one, or we do it again and we want to know what's the probability that the number can be greater than 8 together, the sum of those. Okay, so how many possibilities can there be? Lots, right? So this chart kind of helps you out. It shows on the left-hand side, you can look at that and it says the outcome of the first die, and then up top, the outcome of the second die. And they put those together, so it's kind of helpful when you see the chart laid out, and it probably doesn't make a whole lot of sense when you first look at it, but when you start to navigate it, it begins to make a little bit more sense. So let's look at how this actually works out for us. So the probability that we would roll a sum of 7. The first die would be what? When I actually roll that 7, or roll those first 2 die, am I rolling them at the same time? Yes.
It can be 1 or 6.
Well, I want you to look at that chart down here now, okay? So what they've done is they've actually laid out every possibility for you. So find all the numbers that would total a sum of 7. How many times do you see 7 on the chart? It looks like if I roll a 1 and a 6, I get 7, right? That's the first possibility. So if you look on the column to the left And the row up top, you have a 1 and a 6. So if you roll a 1 and a 6, that's going to give you 7. This kind of looks like your multiplication tables chart. So if you can follow it over and down. The second one, if I roll a 2 and I roll a 5, then I have a sum of 7. So you have to find in your chart, how many 7s do you see there? How many 7s are there?
Well, it has 6.
Okay, so there are 6 possibilities that I could roll to give me the sum of 7, right? I could roll a 1 and a 6, I could roll a 2 and a 5, I could roll a 3 and a 4, I could roll a 4 and a 3, and we go backwards, right? So there are 6 possibilities that I could roll a sum of 7. How many possibilities are there of combinations? How many do you see on here? How many possible combinations could I get in any manner? Not necessarily a sum of 7. How many possibilities are lying on that chart you have right there?
36.
36. So the possibility that I could roll 2 dice that give me a sum of 7 are 6 combinations,
It
right?
would be 1, 6, right?
1 and 6, it could be 2 and 5, it could be 3 and 4.
Would you reduce that to
We
1,
reduce
6?
this to 1 and 6. Okay? Now let's use the chart to our favor again. What's the probability that I could roll a number that is greater than 8? So look on your chart. How many numbers on that chart are greater than 8?
3, 4, 5, 6, 7, 8, 9, 10.
Okay, 10 of those numbers are greater than 8. And how many are total on there?
36.
36. So what does this reduce to?
5 over 18.
5 over 18. Perfect. Okay, so I want you to move down to number 3 in your notes here. 1, 2, 3. Number 3, I want you to write in there what the if 2 dice are rolled, what is the probability that the sum of the dice, oh, we just did that one, is set.
It says 2.
No, wait, that's probably the sum of the dice is 7.
Yeah, we just did that.
I know, why do I have a different answer here? Let me see, I must have read this wrong. Sum of the dice is 7. Okay, well go ahead and build that in there. I actually must have read it incorrectly because I answered it incorrectly. I thought it said greater than 7. So go ahead and build that third example is what we just did up here. And what you might want to do, so you remember how you use the chart, is just circle where you see the different sums of 7. 1, 2, 3, 4, 5, 6. They go down in a nice diagonal row, and 1 and 6 would be the answer for that. Does that make sense, everyone? Yeah? Ileana, you feel pretty comfortable with that? Bailey? Awesome. Okay. So I'm going to look at the next part here. Starting from 70.4, no, 70. Oh, we're on to B. 70.B, which is going to be on page 286. All right, so we want to look now at the probability of future outcomes of independent events that happen in a designated order. Okay, so that's what we want to look at now. This one's a little bit different because this deals with the product of your findings or your outcomes. So let's see how this works. Let's say that we toss a coin. Here's my little coin. We'll say it's got a little president on there with a tie on. He's smiling. Okay, there's my coin. This is heads. What's on the back of a coin? Is it like the Capitol building?
Yeah, I think.
All right, there's our Capitol. So we have a coin, 2 sides here, heads and tails. And let's see, we want to toss this coin 2 times. What is the probability of getting heads on the first toss and a tails on the second toss? Well, here's how we write this up. First of all, we did these last year as well. Let's say we want to figure out the probability of heads first, tails second. This would not be the correct way to write that, although we would get the same answer. If you have multiple times of this, it may not work out correctly. So you want to be very careful. Write it in the order that you're trying to roll it in, because that is the question. What is the probability of rolling heads first and tails second? All right, so somebody tell me, what is the probability of rolling heads on the first roll?
1 out of
One what?
Oh, 1 out of 2.
1 out of 2. What is the probability of I'm saying rolling, flipping a coin and landing on tails second?
1 out of 2.
1 out of 2. So we multiply those and we end up with 1/4. So you have 1 in 4 chances of actually flipping and getting heads on the first one and tails on the second one. Now let's look why this works. Because you might think, I don't really understand why we would multiply this. So let's look at this. So on the first toss,
You got a 50-50 chance.
we're going to take this heads, tails. There's our possibilities, right? On the first one of getting heads is 1 and 2. That one's easy. We get that. Why do we multiply this? Okay, if I roll heads, or if I flip and get heads first, now I need to look, okay, let's take this combination. If I get heads first, let's roll the second toss here. What are my possibilities over here?
Heads, or, yeah.
So on the second flip, I could get heads or tails, right? So the first flip, I can get heads or tails. The second flip, I could get heads or tails, but it's attached to the fact that what if I got heads first? Now, what about if I got tails first? And I flip the second time.
You could still get heads.
You could get heads or tails the second time again. But it's all the combinations. How many do I have? 4. 1 and 4. So if you multiply this, figure out each one of these and multiply them, it actually gives you your final answer. Okay? So let's look at one. All right, 70.5. Let's get a reader for that. Ileana, can I have you read that one?
A fair coin is tossed 4 times. What is the probability that the first 2 times it comes up heads and the last 2 times it comes up tails?
All right, so how do I write my probability problem right here? What's going to go in my parentheses?
HHTT.
Okay, heads, tails, tails. That's what we're trying to find. So that's what you're indicating right up front in your problem. Here's what I'm trying to find the probability of flipping on and landing on. All right, so for each one of these events, we're going to write what the probability is. So Arlie.
1/2 times 1/2 times 1/2 times 1/2.
Exactly. And I get what, 1/16? 1 in 16 chances. 1 in 16 chances that I would actually roll this flip this designated order. Okay? 1 in 16 chances. Okay, let's look at the next one. The next one's about a spinner. The spinner shown here is spun twice. So we have this little spinner, no more using this.
So there's 8 possibilities.
1, oh, that's a 4. I didn't realize that a spinner kind of works backwards here. Is that really true? I guess it depends. I guess it depends who makes the game, right? Okay, so what is the probability that the spinner stops on 4 and then on 3? So what am I writing here? Ileana, what am I going to put inside here? What's the probability that the spinner stops on a 4 and then on 3?
4 and 3.
4 and 3, right? In that order. That's what we're trying to figure out. So obviously we're going to spin twice. What's the probability I'm going to land on a 4 and then on a 3? So let's, Ileana, keep me going here. So how am I going to write this? Probability that I land on a 4?
The probability would be 1/4.
Okay. Probability I land on a 3?
1/4.
So what's the chances that I actually spin and land on a 4 first and a 3 second? Is 1/16. Easy peasy? Okay. So that is the lesson. I'm going to go ahead and log off. If you want to try those practice problems, I'm going to let you guys work on those, and we'll do those together, but I'm already at 25 minutes. So Zoe, go ahead and work on the practice problems, see how you do, and if you have questions, you know you can email me. Alrighty, hope you feel better. See you next week. Bye.